What if our moon disappeared tomorrow? Bended Reality reports. Yes, our moon. To it, over it, shooting for it, blue, green, pie's face, shines, lighting, and I haven't even gone to all the Luna-based concepts. Earth's moon plays a significant role in our culture, language, and thoughts. But does it matter? If it disappeared in the blink of an eye tomorrow, and for discussion's sake, let's assume it does so non-violently, would we even notice? Would we even care? Well, it depends. Do you like tides? Gravity? At least the Newtonian kind is pretty straightforward. The closer you are to something, the stronger its pull of gravity. So stuff that's closer to the moon gets a stronger gravitational tug, and stuff that's farther away gets a weaker one. Easy peasy. When looking at the effects of the moon on the Earth, you can essentially boil it down to three parts: the Earth itself, the ocean close to the moon, and the ocean far from the moon. On any given day, the ocean closest to the moon gets a bonus gravitational pull, so it rises up slightly, reaching out in watery embrace to what it can never reach. And since the ocean is so big, all the water from one horizon pushes up against water from the other, resulting in a fantastic tidal bulge. Okay, tide on one side of our planet done, but what about the other? The solid rocky bits of the Earth are closer to the moon than the ocean on the far side, so the Earth too gets a little bit snugly with the moon, leaving the far side ocean behind, and result, tides on the far side. From the perspective of someone standing on Earth, it looks like that ocean is rising up, but really it just doesn't get to join the party. And there you have it, two tides on opposite sides of the Earth. If the moon disappeared, we would not be totally out of tidal luck. The sun also stretches and squeezes the Earth, so our surfing opportunities would not be completely eliminated. And do you like a 24-hour day? 24 hours in a day. The Earth used to spin on its axis faster than it does today, as in way faster, after the hypothetical giant impact that led to the formation of the moon, which is a topic for a completely different article. Sorry, but at least you can explain the video. The Earth's day was as short as only 6 hours. How do you get it to a leisurely 24? That's right, it was the moon. The moon makes some pretty nice tides, but the Earth is also spinning on its axis. That spinning physically drags the tidal bulge around the planet. So instead of the tides appearing directly beneath the moon, they're slightly ahead of it, normally orbitally speaking. If the moon disappeared, we would not be totally out of tidal luck. The sun also stretches and squeezes the Earth, so our surfing opportunities would not be completely eliminated. So you've got a big lump of extra ocean water in a place where it's not supposed to be. Since gravity is a two-way street, that lump pulls on the moon, like tugging a reluctant dog on a leash. That tidal bulge yanks on the moon bit by bit, accelerating it into ever higher orbits. And by the way, the moon is slowly getting farther away from Earth, and that energy to accelerate the moon has to come from somewhere, and that somewhere is the Earth itself. Day by day, millennium by millennium, the Earth slows down, converting its rotational energy into the moon's orbital energy. If you took away the moon, it's not like the process would reverse, but it would not keep going. That might or might not be a good thing, depending on how much you like the length of your workday. Do you like seasons? The Earth's axis is tilted, and that tilt can change with time. No biggie, all the planets do it, it's fun. But what's not fun is when the tilt changes rapidly. What would happen if Antarctica pointed straight at the sun for 24 hours a day, plunging North America and Europe into permanent darkness? And then a few 100,000 years later, it flipped over. We take the long-term regularity of our seasons for granted, but we might have the moon to thank for it. Those kinds of crazy wild swings in the axial tilt are due to resonances or unlucky interactions with distant objects in our solar system. For instance, let's say that one day in its orbit, the Earth's axis just happened to point away from the Sun, and Jupiter is hanging out in that direction at the same time, and let's say that happens again and again and again, and every time Earth's axis to Jupiter line up and gets a super tiny gravitational pull. At first it's nothing, but over millions of years it can add up, and before you know it, the accumulation of tugs has flipped the Earth over like a pancake. What may stabilize this is the moon. It's really, really big, at least compared with the Earth, and orbits us pretty fast. All that angular momentum, rotational energy, prevents the other planets from playing any axial shenanigans with us. Or not. The moon may actually be hurting us in the long run, since it's slowing us down, which makes us more susceptible to the intrigues of the other outer planets. But it's a billion-year problem anyway, and if the moon disappeared tomorrow, our seasons would still be seasonal for a really long time. So besides the tides, would we notice a disappearing moon? Well, yes, because it's really big and bright, and there'd be nothing to howl at anymore. But would it affect us? Not really. So as for the moon, I'm over it, he says. This is by Paul Sutter, Live Science. He's an astrophysicist at the Ohio State University and chief scientist at Cozy Science Center. He's also the host of the podcast Ask a Spaceman and Real Science. This is on Bended Reality. Now, how far is the moon from the Earth? The moon's orbit around Earth is elliptical. At perigee, its closest approach, the moon comes as close as 225,623 miles, or 363,104 kilometers. And at apogee, the farthest away it gets, the moon is an extra about 30,000 miles. It's at 252,088 miles, which is 405,696 kilometers from Earth. On average, the distance from Earth to the moon is about 238,855 miles. And we know that the moon is actually moving away from Earth at a rate of 1.5 inches a year. So in 10 years, it's 15 inches farther away. Orbital period is 27 days, and the age of the moon is estimated to be 4.53 billion years. Radius is 1,737.1 kilometers. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.